Have you ever stopped to think about how a massive bridge or tunnel remembers anything? I mean, these things are designed to last for 100 years, maybe more. And over that time, thousands of critical decisions get made. So how does a team, 50 years from now, know what was done and why it was done? Well, that's where this idea of project memory comes in. Let's dive into what that really is.
And this quote right here, it absolutely nails it. A project isn't just a bunch of concrete and steel. You have to think of it like a living system. And for that system to survive and actually work the way it's supposed to, it needs a memory. That memory system, well, it has a technical name, traceability.
Okay, so if the project is a living system, then traceability is basically its brain. It's the whole cognitive engine. But what does that actually look like in the real world? To get a handle on that, we need a clear official definition.
So according to the standards, traceability is all about those recorded links. Think of it like a digital breadcrumb trail. It connects a finished piece of work, say a concrete panel, all the way back to the raw materials, the people who touched it, and every decision made along the way. It's the project's official story.
Now, just like our own brains, a project's memory isn't just one big thing. It has different layers. And the first layer is its short-term memory. This is all about what's happening right now, today, out on the job site.
This is the project's working memory. It's what lets the team react to things, keep quality high, and, this is a big one, not make the same mistake twice. The moment a project's short-term memory starts to fail, you immediately start losing control over quality and safety.
And you see this stuff everywhere. We're talking about daily checklists, the sensor logs from a big concrete pour, or those non-conformance reports that flag an error so it can be fixed right away. It's all immediate, operational, and totally crucial for keeping the project running smoothly day to day.
Okay, so that's the daily grind. But all that short-term information has to go somewhere, right? It builds up into something way more permanent. This is the project's long-term memory, and it's built to last for the entire life of the asset.
This is the history book. It's the information that gets handed over to the owner and is used for the next 100 years. Future maintenance crews, engineers, operators, they are going to rely completely on the quality of this memory to do their jobs safely.
And these records are a different beast entirely. We're talking about the final, as-built digital models, the specific batch history of the steel used in a critical beam, and the complete repair history for every important component. This is the asset's permanent fingerprint.
But here's the catch. A project can't, and really it shouldn't, try to remember absolutely everything with the same level of detail. That's just a recipe for chaos, for drowning in data. A smart project needs what we call a priority memory.
This is where the strategy kicks in. It's all about risk. You focus your energy on documenting the things that have the biggest potential impact, on safety, on the environment, on the budget, and on long-term performance. You have to know what you absolutely cannot afford to forget.
And we can organize this thinking with a simple priority matrix. This helps us figure out the right move. So if something is critical and urgent, like a safety incident, that requires immediate recording and escalation. But what about something that's critical but not urgent, like a final design choice? That needs to be permanently archived for the future. This is how a project smartly focuses its brainpower.
So, we get the what and the why. We need short-term, long-term, and priority memory. But how on earth do you actually build this brain for a project?
Well, the answer isn't some magic piece of software. It's all about process and control. You don't get a good memory by accident. You build it deliberately with a system of strong, checkable links that follow industry standards. And here are the 4 foundational steps. First, you give everything a unique ID. Second, you use a traceability matrix to map requirements from start to finish. Third, you establish a clear chain of custody for anything critical, like material samples. And finally, you are constantly auditing and checking to make sure those links in the memory chain are never, ever broken.
And why does all this matter so much? Let me give you a real-world example. Imagine a precast trackpad fails after it's been installed. With a strong memory system, you can trace that one pad back to its manufacturing batch, the concrete mix, the inspection records, all in a matter of hours. Without it, you could be digging for weeks, with costs and delays just piling up.
The stakes here are just incredibly high. The difference between a project that remembers and one that forgets is like night and day. Let's just look at the 2 potential outcomes side by side. I mean, just look at this. When a project forgets, future maintenance is pure guesswork. But when it remembers, repairs are precise, they're informed. When a project forgets, critical safety lessons are lost forever. But when it remembers, that knowledge gets captured and makes future work safer. The difference is just wow.
And this chart really says it all. When a failure happens, the time it takes to find the root cause for a project with a good memory is tiny compared to one that forgets. That difference you see there? That's real time, real money, and a whole lot less risk.
This quote just brings it all together perfectly. We started by calling traceability a memory, but it's really more than that. It's the project's intelligence. It's the actual mechanism that lets these massive, complex systems learn from their own experience and get better over time.
So I'll leave you with this question to think about. Is all of this just a bureaucratic paperwork exercise, or is it something much, much deeper? Is it the very thing that gives our most critical infrastructure a memory, the ability to learn, and the power to last for generations to come?